In the following video, we're going to examine how to find the maximum and minimum values of a quadratic function. And if we have the quadratic function y equals ax squared plus bx plus c, where a cannot be equal to 0, some properties in order to figure out the max min is to determine which direction the graph is going to open. If we have U-shaped graphs for parabolas, they can either open upwards or they can open downwards. Each type of opening has its own property. If the graph opens upwards, then we say that the function has a minimum value, because we see here our graph is opening upwards, and so our vertex actually represents the lowest point on the graph. And that occurs when a is positive or when a is greater than or equal to 0. So if we know our leading coefficient is positive, the graph is going to open upwards, which means our vertex represents a minimum point. If the graph opens downwards, that means your a is negative because it flips the graph. And if that happens, now your vertex is the highest point on the graph. So it's your maximum value. And so your vertex represents the highest point, the maximum point. Now, if we're talking about maximum and minimum value, you think about, the vertex has both an x coordinate and it has a y coordinate because it's a point on the plane. And so which one of those represents the either maximum value or minimum value? Is it our x coordinate, our left and right movement, or is it our y coordinate, our up or down movement? If we think about it as, the lowest point or the highest point, the terms low and high refer to the y coordinate. And so what we can conclude is that the y coordinate is a minimum value when a is positive, and the y coordinate is a maximum value. So if you're ever asked to find the maximum or minimum value of a quadratic function, you need to look at the y value of the vertex, because that's either the highest or the lowest point. Some other pieces of information we're going to have to use as well in this video series is looking at the domain and range of quadratic functions. And so remember, domain represents your left and right movement of a function, or represents the x values. For a quadratic function, we see that the graph goes on forever and forever, up and to the right, up and to the left, and so it goes all the way to the right, all the way to the left forever, so we can say all real numbers represents our domain. Our range is the tricky part. Your range is based off of the y values of the graph. There's two scenarios for your range. If we look at when a is positive, we see that our y values, they're going up forever. However, it stops at that lowest point. And so your y values are that lowest point and up. And so when we have a value that is positive, our y value of the vertex, your y is going to be greater than or equal to the y value of the vertex. And that's if a is positive, because it opens upwards. And you can think about it this way, the y value of the vertex represents your maximum or your minimum value. So we can actually change this. The y value of the vertex is your minimum value. And so we can write that down. We can say, hey, our y value for our range, our y values are greater than or equal to our minimum value, which we should know is the y value of the vertex. Use this logic for when your graph is opening downwards, your y values are going to be less than or equal to your maximum. And that's going to be if a is negative. Now, you don't have to have this concept memorized that, okay, if it's negative, which one do I use? You just have to be able to look at the graph. If a is negative, my vertex represents the highest point of the graph. All my y values are at that point and under. So we use less than or equal to. When a is positive, it's at that point and higher, so we use greater than or equal to. So understand the concept of domain and range with the idea of maximums and minimums to continue on in the video. Let's look at our first example. In this example, we're asked to identify the maximum minimum values of the function. So we have to determine if the vertex represents a max or min, and then to find the vertex. And so when we're given this, f of x equals negative x squared plus 2x plus 3, the first thing I'm going to do is I'm going to identify my a, my b, and my c values. So I see a is negative 1, b is positive 2, and c is 3. So right now, this a being negative 1, this tells me my graph is opening downwards, which means my vertex represents the highest point on the graph. And so my vertex, this quadratic function's vertex, is going to represent a maximum point. Now, in order to find that maximum point, remember, we need to look at what the y value of that vertex is. And so that's where the idea of finding the vertex comes in. So remember, when we find the vertex, we're going to have to do it in stages. In order to find the vertex, you need the axes of symmetry. X equals negative b over 2a. Our b is positive 2, so you want the negative of 2 over twice a, so 2 times negative 1. So I get negative 2 over negative 2. So my axis of symmetry is x equals 1. So when I look at my vertex, that means the x-coordinate of my vertex is 1. Now I'm going to use that value of 1 and I'm going to plug it into my quadratic function. And that's going to give me my y value of the vertex. So y equals the negative of x squared, so the negative of 1 squared, plus 2 times 1 plus 3. So order of operations is do the exponents first, so 1 squared is 1, and then multiply, so I get a negative 1. So y equals negative 1, 2 and 1 is 2, and then plus 3. So negative 1 plus 2 plus 3 is 4. So the y-coordinate of the vertex is 4, which means the maximum value for my quadratic function is 4. Because the maximum value represents the y value of the vertex for it. And so you see how I use my a value, determine whether my graph is opening upwards or downwards, to determine if the vertex was a maximum or minimum point. Used my a and b values to find my axis of symmetry, and then use that to find the y value of the vertex, which represents what for this example, maximum value of f of x equals negative x squared plus 2x plus 3 is. So let's try example number 6. It's along the same lines. Given the following function, f of x equals x squared plus 4x minus 1, we are asked to find the maximum minimum value, and then we are asked to state the domain and range. So that's a little bit different. So let's try it out. So first thing I'm going to do, like before, is I'm going to identify my a, my b, my c values. Here, my leading coefficient is 1, my quadratic coefficient is 1, my linear term coefficient is 4, so b is 4, and c is negative 1. Remember, your leading coefficient determines whether the graph is opening upwards or downwards. And so a being 1 means it's positive, so your graph is opening upwards. So that means your vertex represents a minimum point. And so now we need to find the y value of that vertex in order to get what that minimum value is. So again, to find the vertex, you start with the axis of symmetry. X equals negative b over 2a. So b is 4, so I have negative 4 over twice a, which is 1. So negative 4 over 2, so my axis of symmetry is x equals negative 2. We plug that in to get our y-coordinate of the vertex, which represents what our minimum value is. So y equals x squared, so inside parentheses negative 2 squared, plus 4 times negative 2 minus 1. So negative 2 squared is 4. 4 and negative 2 is negative 8. Minus 1 is going to give me negative 5. And so that tells me, hey, my vertex is the coordinate negative 2, negative 5. And so negative 5 represents my minimum value. The minimum value is negative 5. So no matter what, we're seeing there's a pattern. If you want to find your max or minimum value, I mean, you need to know your vertex. In order to know your vertex, you need to find the axis of symmetry. And so try and find a pattern to how you do these problems. And so if I take a look at this, in this problem, I'm asked to find the domain and the range. And so the domain for all quadratic functions that we're working with, we'll use D for domain, is all real numbers. The range for our quadratic functions, and this is where sketching a picture helps, is we see that our graph is opening upwards, and so our y value is a minimum. So we know our y has to relate to negative 5. We just need to determine, is it going up or down? Is it greater than or equal to or less than or equal to? And since your function is opening upwards, this is the lowest point on the graph, so all values are greater than or equal to that point. And so your range is y is greater than or equal to negative 5. And so you see, in order to know what the maximum value is, you need to know the vertex. In order to know if it's a max or min, you have to look at your leading coefficient. And then you can use all of that information of your vertex to find the maximum value and to help you with the domain and range of the graph. So I hope you found this video helpful with identifying the parts of a quadratic function with maximum, minimum, vertex, and domain and range.